Hello guys, let's get ready for notes on solving rational equations. It's kind of typical for our chapters to go like this. You learn about a certain kind of expression, you learn how to manipulate the expression and simplify it and operate on it with addition, subtraction, multiplication, division, and then you learn how to solve that kind of equation and maybe even that kind of inequality. So that could be coming down the pike as well. So we're solving rational equations where we have one or more rational expression on the left side of the equal sign and one or more rational expression on the right side of the equal sign. Let's keep this in mind. When we get down to the point where we have x equals a number, double check to make sure that number actually works in your equation. Let's say we solve this equation and we end up with x equals 2. What happens if you plug 2 into that denominator? You get 0. So 7 over 0 is undefined. So you would not be allowed to have that. You would have to call that extraneous. So let's not forget to be on the lookout for those kinds of things. Okay, in this first example, I think we have 3 examples altogether. In this first one, we have one rational expression equals another rational expression, one fraction equal to another fraction. What do we call that kind of statement? It rhymes with, in case you need a hint, kind of rhymes with spramortion. Now do you know what it is? That's right, proportion. It's a proportion. So to solve a proportion, you are allowed to use a method we like to call cross multiplying. It's a shortcut. An algebraic shortcut takes care of 2 things at once. So what we're going to do is multiply the numbers on one diagonal, or the expressions, shall I say, and set that equal to the product of the expressions on the other diagonal. So we get 7 times the quantity 2x minus 10 is equal to 11 times the quantity x minus 2. Okay, now we can distribute the 7, 14x minus 70, and distribute the 11, 11x minus 22. Let's gather our x terms onto one side. We get 3x. Let's gather our non-x terms over to the other side, add 70, and we get, what would that be, 48. And divide both sides by 3, and we get x equals 16. Is 16 extraneous? Does it make either one of our denominators 0? It does not, so it is a totally acceptable answer. Let's take a look at number 2. Okay, this one is not a proportion. We do have one fraction on one side, but we have then a sum of terms or difference of terms on the other side. Could you turn it into a proportion? Absolutely, if that's what you want to do. But let's be mindful of the fact that these problems are going to get harder, and we don't always want to use the easy method. We want to use a method that works for the hard problems too. And so instead of turning this into a proportion, I'm going to do something else. I'm going to clear the fractions. And to clear the fractions, we need to find the least common multiple of the denominators and multiply both sides of the equation by it. So, look at the denominators. We have x plus 1, we have 1, and we have x. What's the least common multiple of those? It would be x times x plus 7. Least common multiple of the denominators. So, let's multiply both sides of the equation. I kind of like to keep that 1 as a 1 over 1. Let's multiply both sides of the equation by x and by x plus 7. And as you saw in the last lesson, if I'm multiplying these by multiple things, I'm not going to actually physically cross them out because then I might forget to use them again. So I'm going to multiply the left side of the equation by both of these. The x plus 7 on the bottom will cancel with the x plus 7 on the top, and we're left with 12x. Now I'm going to multiply the right side of the equation by both of those, starting with the first fraction, and there's nothing to cancel, so we're going to have x times x plus 7 minus, and now I'm going to multiply the second fraction on the right side of the equation by both of those, and we're going to get, well, the x's will cancel, so we're going to get 12 times the quantity x plus 7. All right, so no more fractions in the equation, and now we can just continue solving the equation in a normal way. We'll distribute the x, we'll distribute the minus 12, since this one is quadratic, let's get everything over to one side. I'll just subtract 12x from both sides. And we have 7x minus 12x minus another 12x. So 7x minus 24x, that would be negative 17x. Now let's see if we can factor this. That would be kind of nice. You could factor 84 into 21 times 4. So you could do x minus 21 and x plus 4. Let's set each factor equal to 0 and solve each equation. And we get x equals 21 or x equals 4, negative 4, excuse me. Now, double check. Are either of those answers extraneous? Do they make either one of the denominators 0? No. The things that would have been bad would be what? What would have made the denominator 0? Tell me. That's right, negative 7 or 0. So we didn't get either of those answers. So these are both perfectly fine. Okay, let's take a look at number 3. Kind of like the last problem, we have two expressions on one side. We have one expression on the other side. I'm going to put the 5 over 1. And I'm going to rewrite this with my x squared minus 1 factored. So we have 7 over x minus 1 minus 5 over 1 equals 6 over x minus 1 times x plus 1. Okay, so now again, what we want to do is we want to find the least common multiple of these denominators, and that's what we're going to multiply by in order to clear the fractions. So we need to have an x minus 1, and we need to have an x plus 1. So let's go ahead and do this. Let's multiply our first fraction by both of those, and the x minus 1's will cancel, and we'll have 7 times x plus 1. Minus, let's multiply our second fraction by both of those, but there's nothing to cancel, so we're left with 5 times x minus 1 times x plus 1. And then our fraction on the right side of the equation multiplied by both of those denominators are going to cancel, so we're just going to have 6. Now we'll simplify the equation we have now that has no more fractions in it. Distribute the 7. I'm going to leave the minus 5 while I multiply the x minus 1 and the x plus 1 together. Next step, I'll distribute the minus 5. Now again, we have a quadratic equation. Let's get everything over to one side. And I'm just going to go ahead and move everything over to the right side because I don't like having a negative coefficient on my x squared. So 0 equals 5x squared minus 7x. We're subtracting 12 from both sides, subtracting 12 from 6, so we have minus 6. Let's see if this factors. We can do 5x in one of them and x in one of them. If we put a 2 there and a 3 there, we're going to get 10 on the outside and 3 on the inside, so that will be great. Minus 10 plus 3, that's how we'll get our minus 7. Set each factor equal to 0. Solve each one, so we get 5x equals negative 3, so x equals negative 3/5, or x equals 2. Would either one of those answers be extraneous? Look at the denominators from the original problem. What answers would we have to reject if we happen to get them? That's right, 1 or negative 1. But we did not get those. We got 2, we got negative 3/5, so those are both keepers. So we're keeping them. All right. Here is your assignment. Remember to check your answers. I'll post them, and please let me know if you have questions. You guys are doing an awesome job. Thank you for keeping up. And I hope that you are also being good to yourself and doing what you need to do to keep some joy and happiness and keep your stress low. Okay, thanks. Bye.